plot as we are looking at this B6. When we go to plot an ordered pair, and that makes it work in that equation that works. So when we plot that ordered pair is x comma y. Okay? And it says where you plotted some of them, you may notice that a pattern or a straight line or a curve. For real world problems, you should use ordered pairs that make sense to our problem. So we are always going to be plotting our xy points, and then we want to think of numbers that make sense. Now on that B2 worksheet, if you remember when we did domain and range, we're still going to be talking about, because when we talk about the real world problems, a lot of times your domain does not go down here to the negative numbers. So when we think of plotting these, we might only be plotting some of the real world problems in the first quadrant because it doesn't make sense. And the other thing is on that graph B2, some of you had yours extended like a line, and really it should have stopped at like 3 bags because you only had 3 bags of pancake mix to make, right? So you had to stop at this point. So sometimes numbers go on forever and ever, but other times they actually stop. So you guys have to think about that. So when we are looking at problems, we're going to talk about, we've been talking about this the last few days, continuous or discrete, okay? So as you look down at that next part, it says a continuous function is a graph that is unbroken, either a line or a curve. Discrete is a graph that's composed of distinct, isolated points. When you go to buy cartons of milk, you can't go in and say, you know, I want to buy 1.5 cartons of milk, or 1 1/4, or 1.25 of a gallon of milk. You can buy gallons, you can buy quarts, right? You can buy pints, but you can't say I want to buy half of whatever the container is. You got to buy the whole thing. So that is going to be a discrete graph. Whereas when we are looking at over time the temperature, that is going to be continuous because it continues to change. So these are the things that we want you to think about when you're trying to think continuous or discrete. When you decide what is a reasonable independent variable, independent, remember that is your x, right? So independent, that's always on our x-axis. If you can have a fraction or decimal, it's going to be continuous. If you cannot, if it's only 3 or 4, then you are going to have discrete. So discrete, no decimals, no fractions when you're thinking of that. You cannot buy, if you're buying granola bars, half of a granola bar. So no decimals or fractions. Whereas when we're talking about in minutes, you don't have to go from 0 up to 1 minute. You could have 18 seconds. You could have 30 seconds. You have 31, 32, 33, right? So we can have fractions of that time. So your homework, you're going to be asked to graph. And yesterday, I don't think in this class we looked at that decimals calculator for showing linear and nonlinear, but I want to show you that also today. So as we look at your notes, when you're on the test, you want to turn through your notes? Okay. You are going to be asked to graph some equations. When you are graphing, I'm going to need in tonight's homework you to do 5 points. So in this case, what we are going to be taking a look at is that we want to pick 5 different numbers that we're going to solve for x. X is our independent variable. I would like you to put down -2, -1, 0, 1, and 2. Now when you do your homework tonight also, the 4 problems that you need to graph on page 257, you are going to be asked to pick 2 positive numbers, like 1 and 2, 0, and 2 negative numbers. So we want to show the work over here for what we get for y. Y is equal to the absolute value, and first time let's plug in -2. So we're going to put, instead of x, we're going to put -2 minus 4. The absolute value of -2, which just means how far is -2 away from 0, is going to be 2 minus 4, and this answer would be -2. So this is my ordered pair, right? This is my x, my y. So we're going to go to -2, +2. We are now going to plug in -1. Y equals, in place of that x, negative 1, please write this on your paper, minus 4. So we got 1 minus 4, which is negative 3. So at negative, ooh, did we graph that one right? No one was going to say anything. Negative 2, right? Negative 1, negative 3. What happens when you plug in 0? It does something happens. What do we get? We get negative 4, right? If you plug in 0, you get negative 4. Because absolute value of that, so we're down at negative 4. And we do we think this is linear or nonlinear because of the absolute value? Remember yesterday we talked about this one, didn't we? This is not x to the first power. This is a little different. Okay, so let's keep going. So we're going to plug in a 1. So absolute value of 1 minus 4 is going to be what? 1 minus 4. The absolute value of 1 is 1. 1 minus 4. Isn't that going to be the same as here? Yeah, it's negative 3. So is it linear? Not at this point, right? Is it a function? Yes. What happens when we plug in 2? Absolute value of 2 means how far is 2 from 0? That is 2. 2 minus 4 is negative 2. So when I'm at 2, I'm at negative 2. Now, could I have picked a fraction or decimal here for my x values? Yeah, I just didn't because I don't want to get ugly numbers. So we are going to extend this one. This line is going to be an arrow going this way and this way. So on the test, you're going to be asked, what is our domain? This is kind of like that B2 worksheet that we were looking at, right? So what is our domain? What are the possible x values that I could have chosen? X is, in this case, all real numbers. Remember when we had that for some of those ones on the back with the arrows? Okay, so my x value, right, is all real. Where are my y values? What's the lowest y value you have?
Negative 4.
Negative 4. So y is greater or equal to negative 4 for all real numbers. Okay. Now usually you don't have to put this all real numbers after, because if you put greater or equal to negative 4, we're going to know that that's what you're talking about. The question is continuous or discrete, and ours should be continuous. Linear, nonlinear? Nonlinear. Jack.
How do we know it's continuous?
So if we can have a fraction or a decimal. So if I could put in 0.5 here, right? So if I wanted to put in 0.5 on my graph here, 0.5, and if I would have done that, I would have had negative 3.5. So if I can use a fraction or decimal, and I can plug it into this original equation, it is going to be continuous.
Okay.
So continuous is thinking, oh, I can have a fraction or decimal. Continuous is, oh, a number like 3.3 and 3.7 work. Discrete is that they will not work. So we're going to look at these situations, right? So if we take a look and we are, okay, so we want to think about what does that graph look like. We know 1 gallon of milk is going to make us, his recipe calls for 16 ounces if we are looking at that. So at 1 gallon, right, the weight of ours is going to be 16 ounces. At 2 gallons, we are at 32. At 3, we're at 48. Okay, so if we are making this, could you put in a half gallon of milk and make cheese?
Yeah.
Could you pour in 1.5 gallons? So should this be continuous or discrete? Continuous. It should be continuous. So when we look at our continuous graph, we are going to start at 0, right? And this is going to be a line going up. So as much milk as we want to use. We want to use 20,000 gallons, we could, right? Probably not, but. So, domain. What is our domain? Okay. Close. Close to all real numbers. But we got to be more specific because this is a real world problem. And then it can't be what? We can't say, oh, we're going to use -2 gallons. So we are going to say where x is greater or equal to 0. And could you put with that still that it is all reals? Definitely. And then our range. Our range is also going to be what? Where y instead of x, because that's range is always our y values, greater or equal to 0. Continuous or discrete? Continuous. And would you say linear or nonlinear? Linear. So continuous, linear. Okay. So now we're looking at selling it, right? So if we are reading this next part, Maya, want to read that for us?
A farmer sells wheels of cheese for $9. You cannot buy it part of the wheel.
So at 0 he makes no money, right? At 1 he's up to 9, just a little above that 8. At 2, right, we're up at 18. Okay. At 3 we're at 27. So, can we buy 1.5 wheels? No. So we already know continuous or discrete should be discrete. Okay. If we are looking at our domain, the domain, this one is going to be written a little bit differently. It is still going to be greater or equal to 0, but it is only for whole numbers, not real numbers, right? We're not going to have any fractions or decimals. We're talking about buying 1 wheel, 2 wheels, 3 wheels, 4 wheels, 5 wheels, so whole numbers, okay? And our range. If we are looking at the range of prices, again, we would say y is going to be greater or equal to 0. Because you could sell nothing. No one buys your cheese, right? So you have nothing. And again, these are all going to be, since 9 is a whole number, whole numbers. Okay, does that make sense? Yeah. We're looking at that, okay? And linear, nonlinear. Linear. Okay? So discrete, because we can't have fractions or decimals of it, and then linear. On the next page, again, we're looking at some more story situations. So, if we are reading this one, Elise, want to read for us?
The outdoor temperature is about 40 degrees Fahrenheit, more than 1/4 the number of
So it says we want to write a function rule that represents the situation. So we want to look at what's our key information. Key information is that if we are looking at it, the temperature is what? 40 degrees. And it's temperature of 40 degrees more than 1/4 the number of chirps in a minute. So when we are looking at that information, temperature is 40, other key information more than 1/4 the number of chirps in a minute. So we want to identify what is our variable in our situation. So what is our unknown? We're going to use T for temperature and N for the number of chirps in a minute. So part of your assignment is going to be writing functions from a story like this and writing the equation. So we always want to look at that rule, what's our key information. So if we're going to look at it, the key word is almost always, not every time, you're equal. Of is multiply. And if we say more than, you think of being what? What operation? Add, subtract, multiply, divide. Addition, probably more than. Less than would be subtraction. If I say 2 times or twice, that would be multiplying, right? So more than is usually going to be addition. The key word of the is and the of, we are looking at that. So now we want to look at, well, what would our equation be? So temperature, T is equal to 40 more. So this is our equal, right? Temperature is 40 more than, that's plus 1/4 times n. That's what you're going to be writing for an equation. If I looked at this equation, would you tell me it is linear or nonlinear?
Linear.
Variables are both to the first power, right? So it would be linear equation if we were looking at it, right? And we could plug in like 0, and we could plug in the temperature if we are looking at the number of chirps we heard. Maybe we heard 40 chirps, right? We could plug that in and we could find out, oh, the temperature is only going to be 50 degrees outside, right? If we were using this equation. So you're going to be asked to write some equations like this. Here's another problem we want to look at, this next one. It says a landfill has 50,000 tons of waste in it. Each month it accumulates an average of 420 more tons of waste. Joel, question?
How could they figure that out if it hasn't even been there for a month?
So, we are looking at this landfill knows it has 50,000 tons, and each month they know, picking up all the garbage around town, they are getting about 420 more tons of waste. They just know. They pick up the garbage in Fargo, they know that they're dumping, if you've ever been out there to our landfill and seen. So we want to write a function that represents the amount of month we'll have in m months. So again, think about what the situation is telling us. We're looking at our total waste. That's going to be our variable t. So you kind of got to decide what your variables are. And the key situation was m is going to be, a lot of times instead of using x or y, we might use m because we're talking about months. So use m for months and t for total waste. Would you use w? You could use whatever variable you like. They just a lot of times want to make it to make sense to you. Is, again, is our equal, right? Plus times. So what is our equation going to look like? We might have t equals, how much did we start with? 50,000. Each month, 420 times m. Now, most likely when most of you write yours today in your homework, you're not going to have it all this spread out like this. You might have 50,000 plus 420, and we usually don't put that times, and you just have m. Linear or nonlinear? Linear, variables to the first power, right? Each month we're doing continuous addition. Each month the continuous addition is 420. Continuous or discrete, do you think, if we were going to graph that? Do they only bring it in at the end of the month? Or do they bring it in on 1 day in and 2 days in, like you think of our garbage?
Yeah.
So this would probably be continuous, right? So if you're thinking about the situations, always thinking continuous or discrete. Now, I know your numbers, my table kind of got weird up here when it's on this screen. So as you take a look at this, it says, Sean and Jack both like apples. Each week they buy a certain number of apples at the grocery store. Write 4 things to compare and contrast the key features of the 2 functions. So Sean's is y equals 6, or f of x equals 6x. And Jack's is, at first week he bought 4, 12, week 3, 20, 7, 9, and 11, he's at 44. So the first thing, we might want to look, when I think of key features, what I want you to be telling me about key features, I want you to think, is it linear on the test or nonlinear, okay? I want you to think, okay, when we look at week 1 or week 0, so sometimes week 0 or maybe week 1, can we tell how much they bought in comparison to each other? We might want to be thinking about the domain and the range. Okay, so those are my key features of my graph. Continuous or discrete, right? So if we are looking at this one, this does look linear, right, Sean's. How about this one? From 4 to 12, what are we adding? 8. and here I'm adding 8. Am I actually adding 8 a week?
No.
I'm adding 8 every 2 weeks, right? So if we are looking at this, so different things we could say. So are they both linear or not?
Yeah.
Okay, so we're going to put down both are linear. The next thing we are going to put down, continuous or discrete for them?
Continuous.
Continuous. Wait, if you're buying apples,
Oh,
and can you go in for a fraction of it? So we would probably be looking at these because we're doing each week. We're not doing a half a week. They just go to the grocery stores one day, and they buy their groceries for the week. So both are going to be discrete in this case. Okay. Both discrete functions. Do we know that they're both functions? And they kind of told us that. So we just are trying to decide linear, nonlinear, which we said both linear. Both are discrete. So now how about the domains? What do we talk about our domain for both of them? Can we have any negatives? No. So the domain in both is going to be what? X greater or equal to 0. Okay. And for only what kind of numbers? Only whole numbers. Okay, good job. And now we're looking at our range. So on the test, I think I will tell you, like, tell me 2 things or 2 things about each of these. So as much information as you can give. And the range in this case would still be y greater or equal to 0. And we're still talking about just whole numbers, right? So now looking at the people, who's buying more each week? Sean. So that might be something you want to tell me, right? Sean is buying how many a week? Sean buys 6 a week. Buys 6 apples a week. And Jack was only buying 4. He was buying 4. Could you tell me 8 every 2 weeks? Yeah, that'd be the same thing, right? 8 every 2 weeks, but at 1 week, 4, at 1 week here, 6. Okay? So thinking about as many things as you can tell me when we are looking at this. All right. Last one, I believe, before, yes. So, your parents said you can sign up for a music download, and I know this is getting a little old nowadays for one, but service on your phone. And they said you have to pay for it. There are 2 companies that you're trying to decide between. You're not buying that family plan of Apple or Spotify. It's all on your own. You look at the pricing plans below and you're comparing them. Answer the questions below. Let X represent the number of songs that you're purchasing and Y is the money you spend. So X down here on the test, what I'm going to ask you to do is to put labels. So this would be our songs, right? And this would be how much money, right? So dollars spent, something along that line, okay? So when we take the test on Friday, I'm going to ask you to label your axes so I know what we're talking about. So label each function as continuous or discrete and as linear or nonlinear. So, Danelle's music, would you say linear or nonlinear? Nonlinear, okay? So, we're going to put Danelle's is nonlinear. Would you say it is continuous or discrete? Discrete. Are they both discrete? So nonlinear and discrete for this one, right? And if we are looking at JD's, so at JD's, first off, is JD's going to be linear or nonlinear? Definitely linear. So JD's, linear. Is it continuous or discrete? Can you buy a half a song? Can you go to iTunes or someplace and I'm only going to download half that. I don't care about the other half. I mean, either you buy the song or you don't, right? You get to preview and listen or you don't. So again, This one would be if we are looking at it being discrete. Okay, does that make sense if they're both discrete? So how much does each company charge per song? If we are looking at, we can really easily tell in JD's, right? JD's is charging how much per song? $2 per song. But Danelle's, it looks like it starts off at one song is how much? So first song, right? So for Danelle's, one song, you pay $1. And then for each song, up until you get how many? From 1 to 5 songs, you are paying how much for each song? $1, right? It goes up by $1 each time. 5, 6, 7, 8, 9. But after you have bought 5 songs, then how much does it look like they're charging you? Look on your graph and see how many dots until you get to the next dollar. So for song 1 to 5, it's $1. That is kind of linear, that part. And then it's how much after that?
25 cents.
25 cents. Then it's 25 cents a song, right? After that. So like this part is kind of linear, and this part is kind of linear, but together the two are not, because it kind of has that change in our graph that's not a nice straight line, right? So it says, why does Danelle's music start at $4 if we are looking at that? The reason it starts at $4 is that's like your initial fee, right? That might be, you have to pay this initial fee up front. Initial. You have to pay a fee up front, right? So it says, if I'm looking for C of 5 for each company, so if I'm looking at C of 5 for the cost at Danelle's, right? So we would say at Danelle's, right? So when you answer those questions, some of you the other day, you didn't write your function like as an answer like this. So I need you to make sure that you're doing this. So we're going to find C of 5 for both of them. JD's, nice, right? 2 times each song, C of 5 equals 10. If we are looking at Danelle's, we need to look at our graph, and at C of 5, we would have 9. So if you're only going to buy 5 songs, that one is cheaper. But if we continue going, is Danelle's going to be your better buy or the other one? Danelle's after a period of time, right? So you might have started off as we are looking at that, cheaper with you only by 1 or 2 songs. So your homework, I'm going to be giving you graph paper. So you are going to choose 2 positives, 2 negatives, and zeros. You're doing number 9. 23 is a story problem. 25, 27. And then you are doing 12 to 18, which is writing those equations, okay? So I'm going to get you